Hi class, just going to review section 6.1 to 6.3. I believe we did them in class, but just to give you a quick review since it's been about 3 weeks since we did it, and for those of you who weren't there, this will allow you to catch up a little bit. So the first thing we're going to look at is 6.1, which is factoring differences of squares. And so you can see here in the example, we're going to be following these 3 steps in order to do this. So step 1 is we set up this right here, which is a set of brackets with a subtraction sign in the middle of one and addition sign in the middle of the other. The next step is we have to square root the first term. And so in this example, we can see that the first term is x squared. And so the square root of x squared is simply x. And so because we know that the square root of x squared is x, and that x times x equals x, we can fill in the first term of each of the brackets. And then for the last one, again, we can square root 16, and just 16, don't worry about the sign. We can square root 16 and we get 4, and we also know that 4 times 4 equals 16, and so we can put that as the second term. Okay, so we'll just do a couple of examples like that together. We'll skip over that example here and let's just do these together. So you can see here, I set it up. I put my subtraction symbol, my addition symbol. Then if I square root x squared, I get x. So I know x times x, x, and x. And then if I were to square root 1, I would get 1. So x minus 1 times x plus 2. And now I have factored the difference of squared x squared minus 1. Same thing over here. I set it up. X times x equals x squared. If I square root 25, I get 5. X minus 5 times x plus 5. And you can see it continues on like this. It's pretty easy to see this pattern. Okay, so x minus 2 times x plus 2. The square root of x squared is x. The square root of 4 is 2. And that's where I get those values from. I would encourage you to do these 3 on your own and make sure you're understanding. You can also complete any handouts you haven't already completed, which you're given in class in relation to difference of squares. And there's also some attached to this posting on Google Classroom. All right, so that's 6.1. 6.2 is expanding a monomial by a polynomial. So here we have a monomial, here we have a polynomial, and when we expand, what we have to do is we have to multiply the term outside the bracket by all the terms inside the bracket. So if I do x times x squared, I get x to the power of 3. If I do x times 3x, I get 3x to the power of 2. And if I do x times negative 4, I get negative 4x. Okay? And we've talked about why that works. Y is x times x to the power of 2, x to the power of 3. Well, x, we know that. Now, what is x to the power of 2? X to the power of 2 means x times x. So here we have x, and here we have x to the power of 2. And how many x's do we now have here? How many factors do we now have here? We have 3. So we have x to the power of 3. So that's why when we are multiplying powers with the same base, we can just add the exponents. Okay? So here we're powers with the same base. We can add the exponents. 1 plus 2 gave us 3. All right, so that covers that. Let's look at this next question, example question here. If I do negative 3 times 4, I get 12, and I have to keep that y squared. So negative 3 times 4y squared gives me negative 12y squared. Negative 3 times negative 10 gives me positive 30. That y still has to be there because it's still multiplying by 3. Negative 3 times positive 7, and that gives me negative 21, and I've expanded. All right, look at the third one here. 2m times 8m squared. That gives me 16m to the power of 3. 6m to the power of 2 for 2m times negative 3m. And 2m times 2 gives me plus 4m. Okay? And again, I will leave you to work on these 3 questions. Actually, maybe I'll do this one with you right here, just a little trickier, and you can do the others on your own. Negative 4m times negative m squared gives me positive 4m to the power of 3. Negative 4m times negative m gives me positive 4m squared. Negative 4m times 1 gives me negative 4m. Alright, and so you can work on those other ones. And any questions related to expanding monomial by a polynomial that are posted on Google Classroom. Alright, 6.3, common factoring. 4 mental steps when you're doing this. Find the largest number that divides into all the numbers. So here what we're finding is the greatest common factor. And can I take out any variables? If so, how many? So what it means when I say can I take out any variables and how many, you have to look at basically which variable has the lowest exponent, or if there's no variable. So if there's no variable, like this example over here, then a variable cannot be part of your greatest common factor. Okay, you can't take x out of all 3 terms because there's no x here to be taken. All right, so if we do this first, after we do that, it says here divide each of the numbers by the number I found in step 1. Divide each of the variables by the variables you took out in step 2. So I'm going to show you what that looks like right here. If I look at 5x squared plus 10x, what's the greatest common factor? 5. Greatest common factor is 5. What is the lowest exponent? Because that is the only variable that I can take out. What is the lowest variable? The variable with the least exponent. It's x, right? Not x squared, because x squared can't be taken out of 10x. So if it's 5x, that is the term that I put outside of my brackets. And I'm going to fill those brackets. And how can I figure out what to fill those by? Well, it's 5x that I did, so I'm going to divide both terms by 5x. If I do 5x squared divided by 5x, what do I get? I just get x. There's one x left over. 5 divided by 5 is 1. I don't need to write the 1. X squared divided by x gives me x. 10x divided by 5x, and I get 2. Right? Because x divided by x gave me 1. And now I have common factored that term. Okay, so I'll do a few more examples. I think probably my explanation hasn't been as clear as it can be, but if I do a few more examples, you should see what I'm saying. So if you look at number 2, for example, again, the variable with the lowest exponent is this one here, x, right? And so first let's find the greatest common factor. The greatest common factor is 7, or negative 7. Negative 7 divides evenly into both negative 7 and a negative 14. And then the variable with the lowest exponent is x. Can't be x squared, it's got to be x. So negative 7x is going to go on the outside of our brackets. How do I fill those brackets? Well, I'm going to divide both these terms by negative 7x. Negative 7x squared divided by negative 7x, and I'm left over with an x here. And if I divide negative 14x by negative 7x, then I'm going to get positive 2, and that's it, positive 2. All right, and you can always check if you've done this correctly by simply expanding it again and making sure that you get the same answer that you started with. So if I expand this, for example, I'm going to get 5x squared, and if I multiply this over here, I get 10x. Is that what I started with? Yes, it is. Therefore, what I've done here is correct. Same thing over here. If I multiply this by that, I get negative 7x squared. If I multiply negative 7x plus 2, then I'm going to get minus 14x. Did I end up with what I started with? Yes. So I know that this is correct. All right, let's do a couple more, and then we'll end up this video, and then there'll be a brief activity for you to work on. So if I look at this example here, the greatest common factor is only 1 if we're just looking at the coefficients, right? Because there's no other number. This has 1 here, so it can't be anything higher than 1. And then what about the x's? Well, the lowest x here is x, so it's going to be 1x. Or you could think of it as simply x. 1x is equal to x. And so I'm going to put x on the outside of my brackets here. X times what oops, let me write it down here, and then we're going to divide everything by x. We do x divided by x, and what do we get? We get 1. And if we do negative 8x squared divided by x, we get negative 8x. All right, looking at question number 4. Question number 4, greatest common factor between 3, 18, and 9. And the greatest common factor is 3. Now, if I think about the variables, you can see in this example, there's no x here. So x cannot be part of the greatest common factor. So I put 3 on the outside of my brackets here, and now I'm going to divide each of the terms by 3. 3x squared divided by 3, and that just gives me x squared, because the 3 divided by 3 is 1. 18x divided by 3 gives me 6x. 9 divided by 3 gives me 3, and there is my answer. Okay, looking at question number 5, looking at negative 11x squared minus 66x plus 99. The greatest common factor here is going to be 11. What about x's? Well, this has no x, so x cannot be part of the greatest common factor. Now I'm going to divide each of the terms by 11. I'm going to put 11 outside of my brackets, and I'm going to fill the brackets with the terms I get when I divide. Negative 11x squared divided by 11, and that gives me, actually I'm going to make our greatest common factor we can make here is negative 11x. Okay, and so if we divide everything by negative 11, there you go, then we get x squared here. And then here we get 6x. And that's right, it should be positive. Negative divided by negative is positive. Positive divided by negative, though, is negative. And so here I'm going to get negative 9. 99 divided by negative 11. Okay, looking at number 6, if I look at the greatest common factor in this example, it's 9. There's no x because this doesn't have an x. So now I divide each of the terms by 9. I write my 9 outside of the brackets. 18 divided by 9 is 2. 9x divided by 9 is x. Negative 27x squared divided by 9 is negative 3x squared. Okay, so you should see how that works by now, and you should work on the rest of these. I will post an answer key for those questions so you can check your work, but try and do them on your own as much as you can to check your own understanding. Alright, so that's it for this video on section 6.1 to 6.3. Hopefully you got something out of it, and hope all of you are doing well.